Last class I did few theories regarding the force postulate, then radius in nth orbit, velocity in nth orbit, energy in nth orbit, then energy level diagram. Based on that, we are doing MCQs today. I've sent you the PDF, just check. Atoms, molecule, nuclei. Come to page number 12. According to Rutherford's atomic model, the electrons revolving around the nucleus should give rise to. See, electron revolving around the nucleus. Electron is revolving around the nucleus. According to Rutherford, will give what? So first you should know Rutherford's theory. According to Rutherford. According to Bohr, electrons will only give energy when they are jumping from higher orbit to lower. But according to Rutherford, they continuously emit radiation. Continuously they emit radiation while moving in orbit. If it is continuously emitting radiation, that means it will give which emission? Obviously continuous emission spectrum. Hello?
Yes, sir.
This is called line spectrum, where we got different line for different color. If I get range of color for same electron, then it is called band spectrum. But if continuously it is giving something, then it is called continuous spectrum. Black body spectrum is continuous. So first one, it emits continuous spectrum B. Second one. The postulate of quantized angular momentum. Quantized means integral multiple. Quantized means integral multiple. So we know second law was integral multiple of h upon 2 pi. That means it leads to discrete value of orbital radii. No, we don't get different value of radii here. We get different value of multiple of Planck's constant. So option D. Hello.
Yep.
See, again read carefully. Postulate of quantized angular momentum in the Bohr's model will give us Planck's constant. So I can use that Planck's constant. Third, D option. Third. Radius of hydrogen atom in ground state means first is 5.3 into 10 raised to minus 11 meter. After collision with an electron, it is found to have radius of 21.2 into 10 raised to minus 11 meter. So this principal quantum number, or that n final, is which orbit? First orbit is given, nth orbit we have to calculate. What is the relation between R and N? Is it proportional to square of principal quantum number? Bro? Rn is proportional to n square. So 5.3 into 10 raised to minus 11 upon 21.2 into 10 raised to minus 11. This will be 1 upon n square. This is cancelled. 5.3 into 4 is 21.2. So can I say therefore n equal to 2? Correct? No, n equal to 2.
Okay. गवर्नमेंट तो कर रहा है सोशल गैदरिंग रिलीजियस प्लेसेस सब बंद हो गए पार्टी सब बंद कर्फ्यू शायद आ जाएगा नाइट कर्फ्यू स्टार्ट करेंगे
Done.
फोर्थ वन
It was reversed. 90% is now coming from
Fifth one.
The question 3 you did not do.
Oh, sorry. Angular speed of electron in nth orbit is okay. Just one note I'm writing for hydrogen atom. What is radius in nth orbit? Proportional to n square. Correct? Hello?
Yes, sir.
And velocity is inversely proportional to n. Energy is proportional to -1 upon n square. Omega we want. Is omega v by r? Omega is v by r. Omega is v by r.
Yes.
V is proportional to 1 by n and r is proportional to n square. That means omega in nth orbit is 1 upon n cube. And time period is 2 pi by omega. So it is proportional to n cube. Acceleration is v square by r. So 1 upon n square into 1 by n square. That means 1 upon n raised to 4. So therefore centripetal force, which is mass into acceleration, is 1 upon n raised to 4. Right? All related to n.
Done, sir.
Now tell me third answer. Aniket, you only tell third answer.
Your option B.
Option D, inversely proportional to n cube. Option D. Third one, option D. Next. Fourth we did, now fifth one. Any relation between area and radius? What is relation between area and radius?
Pi r.
Area is pi r square. That means area is proportional to r square, no?
Yes.
And r is proportional to n square. So can I say area is proportional to fourth power? Area in ground state is A. Then area in first excited state means second orbit will be how much? It will be 1 upon 2 raised to 4. That means second orbit will be 16 times A. Six. In Bohr's model, the first Bohr's orbit of hydrogen lies at distance of 53.1 into 10 raised to minus 12 meter from the nucleus. The centripetal acceleration of electron. What is centripetal acceleration formula? Is it V square by R?
Yes.
R they have given first orbit ka 53.1 into 10 raised to minus 12. V of first orbit I had told you, remember, 2.189 or approximately 2.2 into 10 raised to 6. Are you remembering? I had told, please remember this. Hello?
Yes,
Yes,
sir.
sir.
Now, what is 2.2 ka square? Is it 4.84? And 6 ka 12? 53.1 into 10 raised to minus 12. So this will become 4.84 into 10 raised to 24 upon 53.1. Now, this if I write as 484, this will be 22 and this is 53.1. Okay? Hello? Hello?
Yes, sir.
Now see 53 into 9, can it be
Yes, sir.
450? So everywhere you see, it is given option 9.22, 9.08, 9.08. So with this definitely 9 point something I will get. So I'm writing 9.08. But power 10 raised to 22 is at only one place. That is C. This answer. If you complete, please tell me. Come up, wait after lecture. Huh?
Okay, sir.
Done, sir.
Seventh one. The total energy of electron orbiting around the nucleus in ground state of atom is. Total energy in ground state is minus 13.6, correct? Hello? Hello?
Yes, sir.
So less than 0, that means minus 13.6 means less than 0. So our answer is A. A. Seventh A. A. Energy of lowest hydrogen atom, lowest means first orbit, is minus 13.6 electron volt. The energy of photon emitted when it goes from 4 to 2. So it should be E4 minus E2 energy emitted. What is E4 value? I had told, please remember. If not, then we have to divide by 16, divide by 4. What is fourth energy? Minus 0.855.
Yes, sir.
And second one, 3.51. 3.41. What is second one? 3.5 or 3.4?
3.4.
Only 3.4. So this is nothing but 3.4 plus minus of 0.855. 10 minus 5 is 5. 9 minus 5 is 4. 13 minus 8 is 5. 2.54 बराबर है अपना 8.55 and 3.4. 10 minus 5 is 5. 9 minus 5 is 4. 13 minus 8 5. 2.45 no. So we can round off as 2.55. D option. Hello? Hello? Hello?
Yes.
D option, no? We can round off. Complete it. No?
Done, sir.
Energy of hydrogen atom with principal quantum number n is given by formula minus 13.6 h. See, no use of this for me because I have parted 5 values. The energy of photon ejected when electron jumps from third orbit to second orbit. What is E3? Minus 1.51. E2 minus 3.4. So we get minus 1.51 plus 3.4. 3.4 minus 1.51. 10 minus 1 is 9. This will become 13 minus 8. This will become 2 minus 1.89 electron volt. That is nothing but T.
Done, sir.
Sum number 10. When hydrogen atom is raised from ground state to the fifth state, ground to fifth, that means higher level or lower level? Hello? Higher level or lower level? Tell fast. From ground to fifth means high level or low level?
High level.
High levels.
High level means potential energy will increase because it is going up. So I can say potential energy will increase. When potential increases, kinetic will decrease because total remains constant. So option B. Done? Come to
Yes.
11. The orbital velocity of electron in ground state of hydrogen atom is v. Then what will be orbital velocity where energy level is 1.31 electron volt? In which orbit energy is 1.51?
Third orbit.
In third orbit, energy is 1.51 electron volt. So velocity in third orbit we want, that means relation of velocity and orbit is inverse. So V1 upon V3 will become 3 by 1. So V3 is V1 by 3. That is nothing but V by 3. Options.
Done, sir.
In a hypothetical Bohr's hydrogen atom, mass of electron is doubled. The energy E naught and radius denoted by R naught of first orbit, radius R naught of first orbit is A naught, and energy in first orbit is minus 13.6 electron volt. Then what will be E naught when the mass is doubled? This is the question. That means energy when mass is doubled, E2 you have to find and R2 you have to find. So for hydrogen atom, radius in nth orbit is epsilon naught h square n square upon pi me square. Except radius, they don't want second orbit, it is same orbit first, but when mass is doubled, what will be the answer? So E naught is how much when mass is doubled. R naught is how much when mass is doubled. So R is inversely proportional to mass. So R naught in first case to that in second is mass of second upon mass of first. So twice of m1 upon m1. So radius of second will be RO upon 2, which is nothing but AO upon 2. Any doubt in radius?
No.
Now energy also we know, formula is minus me raised to 4 8 epsilon naught square n square h square. Therefore, energy in first upon energy in second is mass in first upon mass in second. Mass they are telling doubled. So that means energy will be doubled. Doubled means it is 2 into minus 13.6, which is 27.2 electron volt. So radius is becoming A naught by 2 and energy is becoming 27.2. That is given in option A. Option A. Once you complete, please let me know.
Done, sir.
Okay. Series of hydrogen atom which lies in infrared region. Lyman lies in ultraviolet. Balmer is in visible. They are telling infrared. So can I say bracket? Hello?
Yes.
Okay. Which of the following transition of hydrogen atom will give the absorption line spectrum? Absorption means it is going from lower orbit to higher, then absorption spectrum. Then absorption. But coming from higher to lower, then it is called emission spectrum. So we want absorption. That means it will go from low to high. So where its frequency will be maximum. First orbit is 1, second orbit is 3. So low to high gaya hai. 1 to 4 low to high gaya hai. 2 to 3 low to high. Sab low se high. So where it will be maximum, wherever difference in energy is more. Frequency will be maximum if difference in energy is maximum. So where difference in energy will be maximum? Hello? Where the energy distribution will be maximum?
Option C.
9. 1 and 4 correct. 1 में सबसे ज्यादा एनर्जी रहता है, इसलिए 1 जिधर आया तो पहले तो वो सिलेक्ट कर लेना. Between 1 and 4 C, because N1 is minus first orbit का energy E1 minus 13.6 and E4 minus 0.855. So this difference is maximum 85 maximum. C option correct. Option C is correct. Done. Can we go to 15?
Yes, sir.
15. Wavelength of light emitted is minimum. Lambda is minimum. That means frequency is maximum because they are inversely proportional. Since lambda is inversely proportional to frequency. During transition from light emitted बोला है ना, तो high to low चाहिए. 1 से 2 नहीं जाएगा. It can be either 2 to 1 or 5 to 2. So frequency is maximum where when goes from second to first orbit. Option. Okay, clear? Hello?
Yes.
Yes, sir.
Oh, good. No problem.
Done, sir.
Next. 16. A monochromatic, this is very important. A monochromatic beam of light is absorbed by ground state. So there is some light absorbed by hydrogen atom in ground state in such a way that 6 different lines are observed when it relaxes back to the ground state. Then what was wavelength of incident beam? Nearly, if R is given 1.097 into 10 raised to 7. पहले इसका concept समझते हैं क्या बोल रहे हैं. They are saying बाहर से एक light energy आया और nth orbit पे गया. After taking that energy, it goes to some orbit. Which orbit I don't know. But when it starts jumping, it gives 6 lines. So can I say here, which orbit it went, we don't know. But at that time, we have to combine 2 orbit to get how many lines they are telling? 6? Hello?
Yes, sir.
So if I find number of orbit, where it went, then I know energy in that orbit, energy in first orbit, दोनों का difference ये hc by lambda होना चाहिए ना, जितना ये energy ले रहा है, जितना लेगा उतनी देगा. While coming back, how many of you have followed this part? NC2 is 6. N means orbital number where it goes, combined by 2 together, it is giving total how many lines they are saying? 6. This kind, how many of you have followed?
Followed.
What is formula for NC2? It is n into n minus 1 upon 2. मतलब n से स्टार्ट करना है, 2 टर्म एक एक कम करके. 3 रहेगा तो n minus 1 n minus 2. 4 रहेगा n minus 1 n minus 2 n minus 3 अपॉन ये 2. तो इधर आएगा 2. 3 रहेगा तो 3. 4 होगा तो 4 and so on. मतलब ये अगर 3 रहेगा तो इधर मुझे लिखना पड़ेगा 1 2 3. 2 है तो 1 into 2 खाली इक्वल टू 6. ये फॉर्मूला है. So n square minus n will be 12. That means n square minus n minus 12 is 0. This means n minus 4, n plus 3 is 0. So n is 4 or n is minus 3. But orbit cannot be negative. N equal to 4 is the answer. Okay. So now it is jumping. We got n first orbit is 1 and fourth orbit is 4. And the highest orbit is 4. So what is formula for wavelength emitted? 1 upon lambda in terms of r में जाओ आप, because they have given r. 1 upon n1 square minus 1 upon n2 square. 1 upon lambda, this is 1.097. 1 upon 1 square minus 1 upon 4 square. So 1 by lambda will become 1.097 into 1 by 1 minus 1 by 16. So 1 by lambda is 1.097. 16 minus 1 is 15 by 16. Just copy this one. 16.455. 15 into 7, 105, 35, 13, 15, and 16.455. That is nothing but 97.
Done, sir.
Very important that term. Remember NC2 wala formula. Huh? Whenever they say how many spectral lines are emitted. 17. H beta line. H beta line is second line or first line of Palmer series?
Second.
Second line. H beta line of Palmer series has wavelength 4860 angstrom unit. What will be wavelength of H alpha line means first line. So we know 1 upon lambda is R into 1 upon N1 square minus 1 upon N2 square. 1 upon lambda alpha is R into 1 upon 2 square minus 1 upon 3 square. And 1 upon lambda beta is R into 1 upon 2 square minus 1 upon 4 square. So 1 upon lambda alpha divided by 1 upon lambda beta, R cancel, 1 upon 4 minus 1 upon 9 divided by 1 upon 4 minus 1 upon 16. So lambda beta upon lambda alpha equals to 9 minus 4, 5 upon 36 into. This will be, if you want to take LCM or directly also cross multiplied, 4 minus 1, it will be 3 upon 16. So 16 upon 3. This is 4 minus 1. That is 3 upon 16. Reciprocal 16 upon 3. 4 into 4, 4 into 9. So 20 upon 27. So lambda alpha will be 27 upon 20 of lambda beta, which is 27 upon 20 into 4, 8, 6, 0. 1 0 you can cancel. 2 into 2, 4, 2 4 is 8, 2 3 is 6. So 27 into 243. Roughly multiply in rough. 27 into 243. 27 into 243. 6561 I am getting. So close to this is our answer. 6561, let me take. Six five six one. 6561. 6561 is option C. So whenever it is one wavelength given, other is asked, follow ratio method, that is the best. नहीं रखा है। हाँ हाँ अच्छा नहीं निकला नहीं यार। हाँ मेरा और मार्च का है। हाँ हाँ बराबर, टेंशन नहीं ना कर। नहीं 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 ठीक है। Completed?
Yes, sir.
18th. The ratio of minimum to maximum wavelength. Minimum to maximum wavelength. That an electron in ground state can cause in Bohr's hydrogen atom. Minimum and maximum wavelength it can cause in the first orbit. In the ground state means in the first orbit. First orbit means which series? Lyman? Hello? First orbit, is it Lyman series?
Yes, sir.
For Lyman series, N1 is 1 and N2 is 2, 3, 4 up to infinity. Last orbit will give you minimum wavelength because its frequency will be maximum, difference is maximum. So last orbit is always minimum wavelength or shortest wavelength it is called. Last orbit is minimum wavelength and first orbit is maximum wavelength. This much you have to remember for any series. First orbit is maximum, last orbit is minimum. So we want a Lyman series. 1 upon lambda maximum upon 1 upon lambda minimum. Can I say it is 1 upon 1 square minus 1 upon first orbit plus 2 square, and this will be r into 1 upon 1 square minus 1 upon infinity square. Any doubt?
No, sir.
So lambda minimum upon lambda maximum is equals to RR cancel 1 upon 1 minus 1 by 4, 1 upon 1 minus infinity 0. So lambda minimum upon lambda maximum 1 minus 1 by 4 is 3 by 4. Check, do we have this option 3 by 4? Yes, option C. Have you followed the sum properly?
Yes, sir.
Please keep on going. So not very difficult sums, but we have to be careful with the maximum, minimum or that statement. Calculations in first part hardly something.
Done, sir.
90. If an electron in n equal to 3 orbit if an electron in n equals to 3 orbit jumps down to n equals to 2, then the energy released and wavelength. Now energy released will be E3 minus E2. E3 is minus of 1.51, E2 is minus of 3.4. So minus 1.51 plus 3.4. That is 3.4 minus 1.51. 10 minus 1 is 9. 8. This will become 3 minus 2 minus 1, 1. 1.89 electron volt is given in two places. But without calculation, I can say answer C. Jumps from third orbit to second orbit. So can I say it is H alpha? Hello? This is H alpha line. Hello?
Yes, sir.
So first line of Balmer series wavelength you can remember. It is nothing but 6561 we calculated. So close to that, I can write C without calculation if I know first value. If I don't know the value, then I will say energy emitted 1 upon lambda is R into 1 upon 2 square minus 1 upon 3 square. I will do calculation, but I know the value, so I will prefer writing directly in the exam. Copy 19.
Done, sir.
One more, last we are doing. Same number 15. 19. So that's all for today. Next class, as usual, on Wednesday. Now, today I will send the test paper by evening 6 o'clock. You will complete that paper. Coming weeks, test will be on atoms, molecule, nuclei, whatever I complete that, plus some part means I am telling which part, only potentiometer part of current electricity. Only potentiometer. And atoms, molecule, nuclei, what we complete. So today's test is on light. I am sending at 4 o'clock. Please complete and submit. So that's all for today. Let's meet on Wednesday as per our timings and then proceed.